This is actually something before I started college. I wanted to do something that impacted the world, that helped people. I chose product design, and through this fellowship, I can help people through the specialty that I'm studying. And so if you want to make an impact, there's a lot of ways to do it at UK. My name is Gabriel Portugal, and I focus on product development in my research at the University of Kentucky, specifically the development of a privacy product for international medical brigades in Ecuador. Medical brigades are groups of doctors that are sent on short-term service trips internationally. Typically, doctors set up a temporary clinic where patients are brought in and given free basic medical services. Patient privacy is a big deal in these medical brigades, particularly because these medical brigades are set up for one day. There's not a lot of privacy. So my research is focused on 5 phases. It's the foundation phase, the discovery phase, synthesis, then the last 2 phases are brainstorming solutions, along with ideating and reiterating. So talking with doctors, with people that are part of this program, they're saying, this is great, we need this. Thank you that someone's tackling this.
Hi, my name is Murphy Bird, and my research focuses on the immune response in the meninges post-stroke in Dr. Stowe's lab at the University of Kentucky. This summer, I've been working on a project to determine the timeline of formation of germinal centers in the meninges. The meninges are basically just a covering over your brain and your spinal cord. There's 3 layers, and B cells are what mature in germinal centers. I decided to get interested in stroke research for 2 main reasons. 1, there's no long-term therapy for stroke. And 2, stroke is extremely prevalent, and it has even impacted my own family. I know it has affected many other families, and if I can make one tiny contribution in any way, I'll be pleased knowing that it can be one step closer to a new treatment. Dr. Stowe has been amazing throughout this entire process. She has taught me so many things, from lab techniques to ways to better my scientific methods. I would also like to mention my graduate student, Annabelle. She's taught me how to show up and work hard and just remember the cause that you're working for.
My name is Preet Patel, and my research focus is on elastic fiber changes and their role in recovery in chronic aortic dissection here at the University of Kentucky. My current project does focus on elastic fibers, and they're present in the aorta and in chronic aortic dissection, which is a vascular disease. These fibers have changes, and they're also newly synthesized, and so focusing on the biomechanical properties of them and also just how they're structured as well. Initially, when I started my pre-medicine track here at University of Kentucky, I started shadowing some surgeons and some physicians, and I shadowed a vascular surgeon here who I asked him a question, like, why did you choose Kentucky? He mentioned that Kentucky is a place with a higher incidence of these diseases, and so that also inspired me to do the same because I wanted to go into some kind of cardiovascular surgery in the future. My mentor, Dr. Sawada, has been amazing, and throughout the course of the summer, he taught me all the basic lab techniques, so all the technical skills, but also, along with my postdoc, Sohei, they both taught me the importance of organization, which I feel like has been a major component of my success so far, and it really helps minimize the potential for mistakes throughout the course of all the projects that we've worked on.
Hi, I'm Carter Pryor, and I study chemistry at the University of Kentucky. So, conjugated polymers are a type of polymer. Polymers are repeated units of organic molecules and include things like a lot of plastics, like polyethylene, which makes up grocery bags. Conjugated polymers are just a special type of those that are conductive to electricity. My project revolves around coming up with a new way to study those. I think one thing that I've learned from Dr. Graham is how to really think about problems in materials science. When you come in from another field of research or from a general background in science, you have an idea of what's going on, but not always how to solve problems when you're confronted with them. My project this summer involves taking type of measurement on these materials that hasn't been done before, I've had to spend a little bit of time engineering a setup for this and designing it, printing it. Research is not as intimidating as you might think. A lot of people are happy to work with you. If you don't like it, it really is okay. Don't be afraid to give it a shot. It really does have the opportunity to provide you with amazing experiences you wouldn't get otherwise, no matter what field you're going into. Even outside the sciences, there's a lot of opportunities in research. I highly recommend it.